Hello everybody, today I will be demonstrating one of the most basic and simple set of experiments which are related to types of reactions. So, as you all know, the types of reactions, they are divided into 5 different kinds. First one is synthesis, second one decomposition, third one single displacement, fourth one double displacement, and fifth one is the combustion reaction. So, the materials required for these experiments are kept here and you can observe them one by one. This is iron and sulphur which is required for synthesis reaction, and this is food color, this is soap which is required for decomposition reaction along with hydrogen peroxide and potassium iodide. And the next reaction is the single displacement reaction. For that we need iron and copper sulphate. The next one is the double displacement reaction. For that we need potassium iodide and lead nitrate. For combustion reaction we need ethanol. Let us begin the first experiment, that is the combination reaction. So, what is combination reaction? These are the kind of reactions where two or more elements or compounds react together to form a single product. The example that I am going to consider for combination reaction is reaction between iron and sulphur to form ferrous sulphide. So, here I have taken iron as 2 grams and sulphur as 3.5 grams. I am going to mix both of them and then let us look at the combination reaction that takes place. Let us move on to the next experiment, that is decomposition reaction. Today I will be demonstrating the decomposition of hydrogen peroxide into water and oxygen. So, what are decomposition reactions? Decomposition reactions are those reactions where one component decomposes into many other components. So, this is 10 ml of hydrogen peroxide and I am going to add food color into it. And then few drops of dishwash. And then this decomposition of hydrogen peroxide is a very slow reaction. To make it happen faster, we need to add a catalyst, and the catalyst that I am going to use is potassium iodide. Before I add potassium iodide, let me keep it in the tray, and then now I am going to add the catalyst, a pinch of potassium iodide. Yes, do you observe it? Yes, this shows that there is decomposition of hydrogen peroxide that has taken place with the release of oxygen and water. Wow, doesn't it look amazing? Yes, so as I mentioned earlier, I added a pinch of potassium iodide and it was used as a catalyst. So, for your information, the catalyst never gets consumed in a reaction. It just accelerates the rate of a reaction, and then the catalyst remains as such without any change. So, we are going to use this potassium iodide which is left in this measuring cylinder again for the double displacement reaction. So, let us move on to the next reaction, that is the single displacement reaction. So, now in this single displacement reaction, we are going to take copper sulphate and then the nail. So, let me take some amount of copper sulphate, dissolve it in water, now to this copper sulphate solution I am going to add the nail. So, here due to the high reactivity of iron, it displaces copper from copper sulphate to form iron sulphate. So, this can be observed through a color change, that is the blue color of copper sulphate will be disappeared and you will see a brownish green color which is appearing in this particular solution. So, I am going to heat it. Do you all see that? The blue color is getting disappeared and you can find a bluish green color appearing, and it is almost turned into light green. Yeah. And you see that there is also a brown deposition on the nail and the solution has turned green. This shows that iron has displaced copper to form iron sulphate. The next experiment is the double displacement reaction. To demonstrate the double displacement reaction, I am going to consider reaction of lead nitrate with potassium iodide. So, let me take a pinch of lead nitrate into the conical flask. Let me make a solution of it using water. Okay. So, this is the solution of lead nitrate, and into this I am going to add the potassium iodide which we got from the decomposition reaction. So, I am going to add drop by drop to observe the double displacement. Do you see a beautiful yellow precipitate getting formed? Yeah, this is an indication that the displacement reaction has taken place and the ions have exchanged with another salt. This beautiful yellow precipitate is potassium nitrate which has formed due to the double displacement reaction. Let us now look at the combustion reaction. The example that I am going to consider for the combustion reaction is reaction of ethanol in presence of oxygen. So, this is a conical flask. So, I am going to add some amount of ethanol into it and we see what happens during combustion. So, this is ethanol going to add into it. Rinse it well. Make sure that you do not have any excess ethanol left back in the conical flask. So now you see the conical flask is dry. So let's observe what happens during combustion. Now you see that the empty conical flask has something left in it. Yes, this is due to the combustion reaction wherein water has formed. This shows that our combustion reaction has successfully taken place. So today in these experiments we have learnt the different types of chemical reactions, that is the 5 types of chemical reactions, basic kinds, that is first one is the synthesis reaction, second one decomposition, third one single displacement, fourth one double displacement, and the final one the combustion reaction. Hope you all have enjoyed all these experiments. See you all once again.
We are making these videos so that science learning can be fun and enjoyable. If you like our videos, please subscribe and don't forget to press on the bell icon so that you can keep getting the updates about our latest videos and experiments.